Hi everyone, I'm Gunashri from Sri Venkateshwara College of Engineering. Today I'll be discussing here the subject mathematics, and the topic I'll be discussing today is Introduction to Vector Line Integration, or just vector line integration. So before getting into the topic, let me introduce you about what are vectors. So these are basically the mathematical quantities which will have both magnitude and direction. They'll be commonly used in engineering, physics, computer graphics, and many other fields. So these will be represented by arrows, where the length will represent the magnitude and the arrow mark exactly will represent the direction. So what are the basic properties of vectors? So vectors can be added by using the parallelogram law of vector addition. So here has both has both magnitude and direction. So it can be multiplied. So that multiplication has to be done through a scalar, but it will result in also in the change in the magnitude, but the direction remains the same when it is multiplied by a scalar. So they can be split into different components along the different axes using trigonometry. So what are the vector operations? So first thing is the scalar multiplication. So multiplying a vector by a scalar, which will only change the magnitude but not the direction of the quantity. Next is addition. So adding two vectors will result in giving a new vector, which is called the resultant. It will again be determined by the parallelogram law. Dot product. Uh, what the scalar product of two vectors will give the magnitude of one vector that will be projected on another vector. Next comes the vector representation. Till now, we saw about the properties of vectors. So how to exactly represent the vector? So here, using the Cartesian coordinates, how will we represent us? So we'll represent the vectors in their components along the orthogonal axes. That is the x, y, and z axes. In the polar coordinates, will be representing, it will only the same representation in the wise of magnitude and direction angle. And if in case it is the unit vector, unit vector is also called as a vector which has the magnitude 1, and it is only used to represent the direction. So moving next to vector components. So components again will be the projection of a vector in the different axes such as x, y, z axes. So when we represent in a 3D space, then vector will be splitted down into x, y, and z components. These components can again be added or subtracted independently. So till here was the introduction to what is exactly vector. Coming next to vector line integration. So here it is a mathematical technique which will use to evaluate the integral of a vector field. So this vector field or the integral of the vector field will be through a curve. So it will also use to allows us to measure the total effect of the vector field along the given path or line. So basically it is used in a line which will be used to measure the total effect which will be occurring. So it is this vector integration will be used in physics, engineering, other many fields of sciences. So what is the concept behind this vector line integration, or what is the fundamental concept? So here the notation is integration f dot ds. So for a vector field f which is moving along a curve c, it will be denoted as integration f dot ds, where f is the vector field and ds will represent the displacement along the curve. Here particularly it will also infinite seminal displacement along the curve it will represent. So this is also known as line integral or path integral. It is calculated by summing up dot products of vector field and a tangent vector along the curve. So what are the types of vector line integration? Basically, there are two types of vector line integration. One is a scalar line integration and the one is vector line integration. So scalar line integration is nothing but it will involve the integration of a scalar function with a curve, whereas vector line will involve integrating a vector field with respect to a curve. So what is scalar line integration? So it is used to calculate quantities such as work, mass, flow, electric potential, and so on. So here it is represented as integration FDS. Here scalar function. To specify scalar function, the representation is a slight varying thing. So what is a varying thing is the f is taken into in small letters, and ds again will represent the displacement through the curve. So this will represent the total accumulated effect of the scalar function along the curve. Moving next to vector line integrals. So here these are used to calculate quantities such as circulation, flux, again line integrals of vector field and many other more quantities. So again it is denoted by integration f dot ds, again where represents the vector field and c will represent the curve. So again here it will also represent totally the accumulated effect of the vector field along the curve. So here is a basic example how to calculate a vector line integral. So let me consider a vector line integral such as integration f ds. So specified or given the limits such as f of x comma y is equals to x square comma y square, and the curve is in the line segment 0 comma 0 to 1 comma 1. So particularly now we'll parameterize it the equation as r of t is equals to t1 comma t2, where t varies from 0 to 1. So the tangent to this vector, it will be given by r dash of t, which will be 1 comma 1. That is, it is extending from 1 comma 1. So the vector line integration, the answer integration f dot ds, again you'll get it as 1. So what are the vector applications? So here first thing will come into context is the physics. So it is used to represent forces, velocities, displacement in various physical phenomena. It has enormously being used in physics. Next is the engineering. So it is used in structural analysis, fluid dynamics, and electrical circuit analysis. Moving on to computer graphics, it is also used to represent 2D, 3D objects, transformation, lightning calculations. So next, not only these, there are other useful applications where vector line integrals is vastly used. Why? Because they're vastly used, because they're additive, meaning it can integral over a curve composed of multiple segments, which will be equal to the sum of the integrals over a segment. So it is invariant under reparameterization process, such that it is independent of the choice of the parameterization. So here I conclude my topic. So it is the most powerful mathematic tool which is used to evaluate the integral of a vector field. So it will also use to allows us to measure the cumulative effect of a vector field along the given path, line, curve, any other parameter. So because of its widely used applications in physics, engineering, and scientific disciplines, it has been widely used. I hope this video was useful. Thank you for watching.